This is part of a video that we have in series to pin out this Nissan VQ35DE wiring harness from the E50L Grand. In the process of doing so, we have found out the Nissan Motor Company USA is perpetrating a fraud by providing irrelevant literature when compared to its product, item, or device. Most of the time, when an automotive or a car company provide irrelevant information, the technician and the mechanic is unable to fix that vehicle. That is why you see so many Nissan are garbage and you never see any classic Nissan. So let's continue this video to show you that we have purchased the L Grand manual, the Infiniti QX4, and the Pathfinder manual for the VQ35DE to compare to this wiring harness that we have on a 2001 Nissan L Grand JDM, not US. This harness is from Japan and it's not from the USA. So it doesn't matter if we purchase, which we've already done, the JDM wiring schematics from the Nissan dealer or the US wiring schematics. None of them can identify the wiring harness. This is the greatest fraud I've ever seen in the automotive industry. Let's continue with this video and show the nonsense that Nissan is providing. It's such a sick company. Listen to the names. Sneeze on. We can see it's a solid red with a black stripe. So the circuit on the diagram confirmed differently than what we are witnessing right now. But we're still going to test this wire circuit to confirm where we think it should exist based on experience. So this wire should basically come out on any one of these main harness plug that will travel through the dashboard going to the gauge cluster, the evap system, and body control, plus other options. We're going to look in these connectors for that wire, because here we can see a red, but it's a red and white wire. So that's not our wire. So we're going to flip this over. We're going to try to look again for another red and white wire. Another red and black wire. So here we can see one right there. So let's test that circuit with this ECM pin to see if it's on the same circuit to confirm what we are trying to achieve as identical with this factory blueprint wiring diagram when confirmed to the physical harness. Okay, so what I have here is a 12-volt bulb connected to a 9-volt battery, and it's circuit in. So when the two ends touches together, it will illuminate the light bulb, letting us know that it's one circuit. So here I'm going to look over here. You see it's on the 3rd pin cell block. Now I just want to take this and make a contact on the 3rd pin to see if the light bulbs become illuminant. And as we can see, that's not the case. This circuit is not a power distribution circuit as confirmed in the 2002 US model VQ35DE engine control. So we now have to disregard this circuitry from the vehicle manufacturer dealer because it's not identical to the physical harness that we have before us for the 2002 Nissan Pathfinder USA Federal model. We will not move to the next pin. You can do so if you had solid evidence that this circuit was what it claims to be in the factory manual and the wiring harness removed from a vehicle of that year, model VQ35DE, claim in the specification here. And also, to further confirm that this is not the correct wiring schematic blueprint, the ECM harness plug is different. So we have to go to a wiring blueprint diagram that has a ECM harness plug like this, but instead the ECU harness plug that we currently have looking like this with our specification. We have to look at the stack of the pin. You see up here have a longer stack than the bottom, and here we have a longer stack than the bottom. Same thing over here, here, and here. And then we have to look at these in the corner here. But how we're going to know if this connection, we're looking at it correctly, is that you want to make sure this stack is on top, the long stack. So here is the layout of that harness plug, and this is the long stack. Here's the short stack, and that's the way it goes all along with the cell blocks. Okay, this is the same circuit that we were looking at with the 2002 VQ35DE wiring diagram from the vehicle service manual from the dealer. So here we can see that that same circuit we're looking for is over here. This is the ignition switch. That's the fuse block. We can see it says B and W. That might be black and white or blue and white, but it's most likely black and white. Normally black and white will specify BLK and with a Y, but we're going to assume this is black and white. And then it comes from a main fuse. This is most likely next to the battery, the main fuse box. And it shows that it's white and green before it hits the ignition switch. Then it comes out the ignition switch as a black and white wire into the interior fuse compartment and enters the ECM by a connection like the main harness, because we can see here it's specified M, right? And that's F. So this is like M33 and that's F22. So that's basically the male and female connector for one of these three harness plug that goes to either the gauge cluster, the fuse box like we're trying to verify, evap control, and other related option for controlling the engine and monitoring operation of the engine system. Now we want to go and look at this wire at pin 43 on the ECM to see if it's a power source circuit as claimed in this wiring diagram for the 2002 Nissan Pathfinder workshop service manual. Okay, since this is the ECM harness pin layout cell block, so we want to find cell block 43. Cell block 43 is what we're going to test to verify if it's a power source circuit from the ignition switch and the interior fuse box. Okay, so number 43 is going to be 5 cells in. 1, 2, 3, 4, 5. So this is cell block number 43. So we're going to insert our probe onto this connection to check the wire. A reverse side look at that harness plug. We're going to see number 5, which is 1, 2, there's a space in between for 3, 4, 5 is a blue wire. So we have to take a closer look at this blue wire. That blue wire is substituted for this red wire, which is at pin 43 on the ECM harness plug. Now I want to look at the circuit where it makes its travel from the ECM to the fuse block. I want to see if there's any connection between this wire, and here it will confirm that there is, because there is an M33 F22 connector. That's a male and female connector, And in that pin connector, this wire exists at cell pin terminal location number 11. So we have to scroll down here and look at, when we take a look at that M33 gray connector, we'll see we have 9 terminal pin connection in that socket. To the right we have 4, and on the left we have 3. This blue wire that we have just identified shows up here on this gray plug. So we want to check for live circuitry that it is in the same circuit. With the test probe in place on that blue wire, we're now going to test to see if we get continuity to specify if the circuit is alive. Okay, so this is going to require playing with the connection, but here we can see we have established connection to confirm that this is a live circuit. So obviously that light bulb is not bright as it should because that battery is practically dying. But this has confirmed that this circuit is 1. So now we have to follow this wire, which we know goes to the main harness and is most likely a wire that will end up at the ignition switch and the fuse box like we wanted. If it confirmed to be the case, then we will continue to check additional power circuit for the ECU and all the ground wires that we have dissected from the ECM harness before to confirm that this harness is most likely identical to this 2002 Nissan Pathfinder workshop service manual. Once we have confirmed that, then we can move on to addressing additional circuit wiring by labeling and tagging that wire for future reference when building the harness into the vehicle. Since we cannot locate this M94 and F22 connector here, we're still going to make a test based on the wire color, since we found it to be white and red. So that pin will locate right here. So let's check the color of that wire for that terminal. When we look at the reverse side of the harness plug, we will see that red and white wire, but it's not where specified. Instead, this red and white wire is at pin cell number 1. So we flip it around again. You see that where it is? It's at the top most, or should I say the bottom most left. And when we flip it up, it'll be at the top most left. So that red and white wire has to be tested for its main harness connection at M94 pin number 18. Next thing we want to do is strip away this conduit from the entire wiring harness to reveal more information about its operation, network, and circuitry. This white and red wire, which is our test probe insert, turns up on this brown harness, which we had before is M33. We located at this position here. Right here, that's a red and white wire. So let's flip this around and test. This second wire is connected to this pin right here. So there we can identify that is the same circuit, and this is the second circuit that is confirmed live but is not specific to the Nissan service manual. So this wiring harness will have to be detailed and specified based upon knowledge and experience verifying with other manuals. Here you can see is the same method that we took for verifying if that circuit is alive with the bulb and the 9-volt battery. Instead, they're using a multi-volt meter, preferably testing on the ohm scale. So this is the harness plug that we want to see in our diagram to verify what we have just done in that general blueprint for the VQ35DE. This blueprint is for the 2002 Nissan Pathfinder Workshop Service Manual, which is made specifically for this vehicle with the 3.5 VQ engine. Our next move is to place some form of tag or label on these two wires that remain true against the vehicle service manual from Nissan. To prove a fraud or misinformation is being provided by the factory service manual on these harness, let's take a look at, in the previous video, we can identify that the JDM wiring harness for the VQ35DE engine and the Pathfinder are not the same when compared. Even if we compare the JDM VQ35 harness to the wiring schematic, they're still different. Same thing goes for the Pathfinder when compared to the factory dealer wiring schematic. So none of these wiring harness or literature are basically identifying any of each other to be the same. Only some of the circuits are turning up to be the same. So most likely a dashboard harness, main harness, will have to be purchased to identify the wires for the transmission control module and other device. Here's a website on the internet, obviously. See, that's the name. And this website, approximately a month ago, was hosting all the factory service manual for Nissan Infiniti. Now you can see this website was served with a notice by the Nissan manufacturer to remove all the service manual for all the vehicle that Nissan make. Can you imagine the misinformation that they're providing on all those vehicles to prevent technician and mechanic from fixing them? So this site is basically shut down because it does not have wiring schematics no more. It's simply just a car forum for the nerds to communicate on. But they do not know that the Nissan dealer is perpetrating with a fraud on these manual. So now they find out, since the dealer must have saw my first video and says, whoa, he's correct. Our factory service manual is not comparing to our product. So they must have contacted this website and shut them down. Because since the engine that was sold to us was sold as a 2002 to 2004 Nissan Pathfinder QX4 from the eBay auction. That will be a JDM seller. Here is the eBay seller most extravagant advertising for the item that we purchased is a E50 L Grand VQ35DE engine. Based upon the information provided in this workshop service manual, which is not a Nissan product and is a copyright, we are only questioning the wiring harness for the E50 R50 model VQ35DE. This book has basically confirmed to us that the engine is for the El Grand model vehicle and not the Pathfinder or Infiniti QX4. We have based our knowledge of the engine, year, make, and model, providing the information in this El Grand workshop manual by comparing its exhaust manifold, engine mount bracket, and vacuum lines for the power swirl valve. The ECU factory tag has also confirmed for us on the Google search engine that it is a El Grand E50. Also, the serial number on the transmission tag has verified the engine transmission wiring harness is from a 2001 Nissan Grande E50. Based upon our research, information collected on the US wiring harness and the JDM wiring harness are most different in color when verified against the same pin location on the ECU. With the two harnesses relating the same information at different location pin on the ECU, this should not be the case unless the dealer corporation is using many different subform of company to make wiring harness for the same engine with different identification and pin location. With different identification and pin location physically on all the harness, the factory dealer service manual is only specifying the same instruction for all make model on the 2002 to 97 Nissan VQ35DE. With different color wires, the wiring schematic in the factory service manual still does not compare. Let's take a look at repairing these two shield wires for the wiring harness. These two wires goes to the crankshaft position sensor, and this one here is for the rear of the crankshaft, which will basically read from the flex plate, and this one here, which is basically the plug for the front crankshaft position sensor, which reads its signal from the harmonic balancer. So we have already established identical color in the wires that we're going to be attaching. But what we must understand about this wire is that there is 3 wires in this shield wire, and you will see one of them is a stainless steel wire, then we have a signal wire, and then we have a ground wire for that signal circuit. All these wires are basically wrapped in this aluminum foil. The understanding that must be gained from this aluminum foil is that one side of the aluminum foil conducts electricity and the other side don't. For example, when we take our test tool and we place it on the reverse side, on the outside of the aluminum foil, we will see it does not really conduct electricity. But when we go on the inside of the aluminum foil, we can see it conducts electricity. So since these two wires are completely separated, placement of this aluminum foil is important. So we're basically going to want to lap it like this, and we could see on both sides of the wire we have a shield, or should I say a stainless steel wire. This stainless steel wire is what provides the continuity on the inside of the aluminum foil for the length of the wire. So putting these two stainless steel wires together is going to become challenging because the solder iron is not going to be able to solder these two wires together. So in some event, first going to have to position the wire like this, where the two aluminum foil meets at a cross, and then we will have to wrap it together. So let's take a look at doing this. So this is going to have to take the utmost care, because if the aluminum foil becomes destroyed, it's going to avoid contact with the stainless steel wire, and this is going to promote problems for the circuit, causing malfunction. So we want to make sure we have all these wires together making sure that there's no strand or excess hanging out on the side. So like I've said before, it's not such a good idea to repair these wires. It's much better to replace them the full length. So this here is basically connect together. We're going to take a piece of tape. Now I just want to attach this tape to the aluminum foil on the outside of the shield cable, holding it for us so it remains like this. So now what I want to do is I basically want to press this stainless steel wire down into the aluminum, or should I say the aluminum foil. See the stainless steel on the side here. We want to hide it inside the stainless steel. We want to hide this wire inside the aluminum foil as originally. And we will close this aluminum foil for maintaining a shield circuit the entire length of the wire, while these two wires are going to remain on the outside for soldering. So first we have to basically electric tape, duct tape. Preferably it's better to use electric tape since it has the ability to withstand approximately 400 to 500 voltage and also interference. Okay, so we have to make sure we can just secure this. Now, placing the electric tape is very important because remember now we want to cover the shield wire and preventing it from coming in contact with these red and green wire when they should be soldered together. Now we have to position these wires away from one another when we solder them. So now we have to use our wire stripper tool and strip away the edge, the end of the wire for connection. With the crankshaft position sensor on the wire itself, it's going to contribute to some weight when it comes time to soldering the wire. Pay attention to the end of the wire at the limited insulator that was stripped away. That is the connection we are trying to establish. Now it's time to solder those two wires together and finish the connection of the crankshaft position sensor shield wire. Let's take a look at soldering these two wires. And the first thing we want to do, we want to make sure we preheat our tool with a soldering gun. This is my Wells model D550. This is an old school soldering iron and it's very powerful. Once we could get this wire heated up, then we're going to insert our wire, the solder wire, onto it. So we could use the solder wire to press onto the wire. Repositioning the wire is going to become most essential. You can see on the green wire how it started to burn the insulator. That's because of the heat from the solder gun. Now holding these two wires together are going to be the most challenging part. So to ease that challenge of holding the two wires together, I'm simply just going to heat one side of the wire, saturating it with the solder. I'm going to do the same thing on the other side. All I'll do is just bring them together now. So we have to allow the wire some time to cool because the solder iron could cause the insulator to melt. Okay, so I basically just bend the two wires together so they could touch. Now I just want to go in here and heat the wire. And that will cement the two of them together once they're cold. So there we can see we have made contact on our wires. So now it's time to fix this wire to the position that we want it. And now you're going to see where the connection is. It will most likely come in contact with the aluminum foil. So this area has to be covered with the electric tape. So it has to get lifted up a little like this. Then I just want to cut basically a 1 roll length of electric tape to protect that area where that aluminum foil is exposed. So we're going to do this on this side also. Once we have insulated those areas, we're going to press down on this wire, trying to make it as smooth as contour as possible with the shield wire itself. Then I'm just going to take the tape from one end. We want to do this part nice because remember now we want to seal connection here. We want to just wrap the tape nicely so it's sealed perfect, because this is where we're going to have to prevent water from entering or moisture this connection. Now, that is something acceptable right there, but we're going to take the tape another layer back. We're going to go back this way because this is our final repair. Now we're going to do the same thing, the crankshaft position sensor shield wire for the front harmonic balancer. So this is basically bring us to the end of the repair. And always remember, it is always best to replace the full length of the wire instead of making a repair like this. During the installation of the wiring harness, when the engine is started and the vehicle started to drive, this wire will have to be monitored with the scan tool, making sure that it does not detect any DTC code. Any DTC code relating to the crankshaft position sensor will most likely be the cause of this connection. So on this wire here, we have the shield wire and we have a black and white wire to attach. In addition to this wire that we just repaired for the crankshaft position sensor, you see we have 3 wires which we just fixed, the red and the green. Now it's time to connect this white wire, and this is a signal wire from the ECU, because here you can see it basically goes into a juncture where it splits into 3 wires. So this will basically just get soldered here, and that will complete the circuit for the crankshaft position sensor for the flex plate, also known as the flywheel. With the additional wire connected, now we could go ahead and make that solder connection. So if you notice, I'm not wrapping these wires together because I want a very, very short connection, and I do not want excess amount of wire to be exposed when the electric tape is being sealed the connection. Okay, so you see what's going on here? It's basically melting the conductor for the wire. That's because this is an extremely powerful solder gun. I doubt whether you're going to find it on the market today. It's from the Welder company, and it's D550 24. I just want to get this saturated. Okay. So you see, the good thing about this is that you can release from the trigger, allow the gun to cool. That basically has held the wire together for us. Once you have established your solder connection, you want to pull out the wire as hard as you can, making sure that it doesn't break apart. Because the wire individually by themselves like that, it's very, very difficult to stick them together with the solder iron. So that's complete the individual circuit for the crankshaft position sensor. Here again you can see we have made the same connection, basically pushing the connectors away from one another and sealing the aluminum foil away from the connection with our electric tape. I want to press down on this wire, making it smooth with the shield wire. Now we're going to use the roll of tape and wrap this complete wire nicely. The repair to the crankshaft position sensor at the flex plate and the reference sensor at the front harmonic balancer is most essential for getting the engine to start. This will be the best way to bypass the security system. You see, most of the time you will have to get the security key, which is a immobilizer, and then you have a smart unit. Then you have the ECU. Then you have the crankshaft position sensor, POS, that's the flywheel. Then you have the front, which is the reference signal. And these two basically have to go in to the smart unit. The key is required to communicate with the smart unit, not the ECU. So this ECU needs to see these two signals to command the fuel injector and the spark plug. If it does not see these two signals, the operator or the driver will continuously crank the vehicle, the engine, and it will not start. So the ECU communicates with the smart unit. Or sometimes it has what's called a BCM module, body control module, which is also controlling the windows. But I don't believe this has it. Maybe it's integrated into the smart control unit. But anyway, the BCM and the smart control could also be the same thing. But what you need to know is that the BCM or the smart control has to communicate with the ECU. And when this happens, it's basically referring the sensor signal from the flywheel and the front pulley, harmonic balancer, to the ECU. In order for this to take place, the smart control or the BCM must see a security data code from the ignition key when it is initiated on. Once it sees that code, it will basically close the relay circuit internally and refer the signal for the two sensors to the ECU, then the vehicle will start. If the key or the ignition lock is to become broken and the operator tries to start the vehicle, the smart control unit will not see the key signal because there is no key, the ignition is broken. So it will not close that circuit to refer these signals to the ECU, preventing the vehicle from starting. So I hope you can understand what we have just done with these crankshaft shield cable wiring harness.